Hello, this is Mrs. Nearing, and I'm going to talk through what you should be doing on Friday the 23rd. So hopefully you're maybe in class right now and you're thinking about the lab and what you're going to do with it and how you're going to interpret all this data. So the first thing I want you to do is to go look at the pre-lab assignment. And I know a lot of people hadn't watched any of the videos yet, so I would like you to go and watch this overview of lab number 2 and then maybe come back to that later. It's a flowchart saying what all the steps of the lab are and what it is we're trying to do. And then I would challenge you to try and explain it to somebody else too, to make sure you understand what we're doing and why and what we're going to use all that data for. Okay, so now next thing I want you to do is to make a graph. So I want you to go over here and look at your Excel directions and click on that and open it. And if you might be zoomed in on it, so you can kind of like zoom out a little bit so you can see it a little better. And then I'm going to drag this over so I have two windows open, and I'm going to go over here and open an Excel document. Okay, I'm going to open a blank workbook. I'm going to make these here side by side. So I've got my directions and I've got my data somewhere written down. And everyone's going to be making their own graph, because being able to make a graph in Excel is a very useful skill that we all can learn how to do by following these directions. Okay, so we've got our blank workbook, and we're going to write headings in the columns as the first step. And notice it said it's actually okay to skip this step if you want to. Okay, and and I just want to point out I am using fake data here, so don't try and use my data as your own. I'm going to put in some absorbances here. I've got 0.4, 0.3, 0.2. Sorry, these are my molarities. These are my various concentrations. So I took my 0.4 molar copper nitrate and I diluted it down to 0.3 molar, 0.2 molar, 0.1 molar, 0.05 molar, and then I had 0 molar. That was my water. Okay, 0 molar water had an absorbance of 0, because that's what we use to blank the sample. So that can be a data point 0, 0. So pure water has 0 absorbance. You kind of define that using your spec. And let's say my 0.4 molar sample had an absorbance of 1.091. My 0.3 was 0.817. Again, this is made up data, so don't use this as your own data. 0.475 and 0.136. And you might be noticing over here these molarities, they're only to 1 sig fig the way they're written. If you ever want to increase your sig figs on something, you can highlight it and then you can go up over to there's these decimal tabs here. If you hit it this way, you're going to add decimal points to it. So there you go. Now I've got my molarity to 3 sig figs, and all these numbers are to the thousandths place. Okay, so now I have my data inputted. Notice I did not put units by anything. It turns out absorbance is actually a unitless value anyways, but you don't want to put units into your Excel document because that'll mess up the way that it reads the numbers. All right, so I'm going to go back over here. I typed in my data. I'm looking at my directions here. And see if I can get this to scroll down. There we go. Okay. So, sorry, my screen was malfunctioning. So I typed in my data, and then I'm going to make a graph. So it looks like next step is highlight the columns that include your data. So I'm going to go over here, back to my Excel document. I'm going to click on the A. I'm going to hold it with my left click it, and then I'm going to drag across to B. So now I've highlighted my data. I'm going to click on the Insert. So I'm going to come up here, Insert, Tab, and I'm going to look for Scatter Plot. And you might assume you should make a line graph. We actually want to do a scatter plot. That's what Excel calls it. And let's do the one with no lines connecting it there. So here's a scatter plot. And then I now have a graph. Okay, so I'm going to go back to my directions. What do I want to do next? Well, when I kind of hover over the graph, there's going to be where is it? If I click on the graph, there's going to be this little plus sign right here. And if it says chart elements, and if you click on it, you can add things like axes titles. So if I click on that, I now have axes titles, and I can just double click on the box here and add in a title. So this would be like the concentration of copper in molarity. Okay, I can double click on the title, and I'm going to change to something that is meaningful. Okay. And I want to know the equation of this line. So I'm going to let's go back to my directions, because again, my screen is not really cooperating here. Oh, here we go. So I want to add a trend line with an equation. So if you zoom in these directions to the right, it tells you how to do that. So you click here, and I'm going to add a trend line. So notice it's this option down here. And if you click on the arrow off to the right, it gives you more options. So to add a trend line, I want it to be linear. Okay. And one thing you want to make sure you click on right here is set the intercept to 0. So 0, 0 should be a data point. And you want to display the equation on the chart, because we're going to use that equation in our calculations later. Okay, so now I'm all good with my trend line, so I'm going to close this back out. And I have a trend line, and the equation for it is right here. Notice I have one data point that definitely looked like an outlier. So, and it kind of just got ignored on the trend line, so that's good anyway. So once you make this graph, you'll be able to take a look for outliers, and you can think about that in your error analysis. Was there something that went weird when you were making that one solution? And this graph right now, this equation of the line tells you y equals 2.79 times x. And if you think about what these things stand for, your y is let's label the y-axis. What is the y-axis? It is absorbance. So y is absorbance, and your x-axis is concentration. So your absorbance equals 2.79 times your concentration. So that means that when you take the absorbance of your unknown, so you should have also taken the absorbance of your unknown, your brass solution there, and let's say the absorbance of it was, I don't know, 0.752. Okay. There's two different ways you can think of it. So you got this absorbance 0.752. You could look down here in your graph and say, okay, where's 0.75? And then kind of read over and say, all right, what molarity would that be? It looks like that would roughly be about like 0.257 molar. A more accurate way of doing this would be to plug the numbers into the equation. So you're going to take the absorbance of your unknown sample, 0.752, plug that into the y value over here of your equation, and then you're going to rearrange it to solve for x, and that will give you the absorbance of your copper solution. And I apologize, I'm not writing this out. I lost my stylus, so I am making do here. So you're going to use this equation of your standard curve here made with your solutions of known concentration to figure out the concentration of your unknown brass sample. And then once you have the molarity of the brass sample, you know the volume of your brass sample, you'll be able to find moles of copper, and then from that you'll be able to find grams of copper, and from that you'll be able to find mass percent of copper, which will just be grams of copper divided by the grams of your total brass sample. I will go over here and point out in OneNote, you also have off to the side a set of sample calculations, just like we did with the previous lab. You see there's lab 2 practice calculations, and there's an answer key down here as well. And some of the practice is just involving sig figs, to be thinking about that. But there's some practice with like a sample set of data here, so you can try that, talk about it with people in your table, check your work here on the answer key. So that's something else you could be doing. So today I would watch the video, give an overview of the lab, make a graph, get an equation of your line, see if you can use that to find the molarity of your unknown copper solution, and then maybe try the practice calculations first before you go any further with your own lab calculations. And then let me know if you have questions. You can send me an email. The lab's not going to be due until next Friday instead of Tuesday, so I'm giving you a few extra days because of the extra technology kind of stuff we have to do here. Okay, have a great day.